Water is it's a pretty amazing thing. Aside from the fact that it quenches our thirst and keeps us hydrated, and it provides us some of our favorite things to do and places to go, water has some really unique qualities that make it so important, that make it so special to us. And so we're going to do a series of labs to try to demonstrate some of those unique qualities of water. This first one that we're going to do is a cohesion demonstration. Cohesion is water's unique ability to stick to itself. Because of its hydrogen bonds, it has the ability to, the water molecules just like to cling to other water molecules. And when it does, it acts a little bit differently than other liquids do. So for our demonstration here, we've got our parchment paper, a couple of these guys, droppers, and then just some water and some rubbing alcohol. And I'm going to show you the difference between what the rubbing alcohol does and what the water does. So let's do the rubbing alcohol first. Let's get a little bit straight out of there. And I'm going to put it onto the paper and we'll see what it does. Let me put it on there. Hopefully you can see that. There's not much to see. It really spreads out. Now, with our water, it's going to try to cling to itself. These molecules are going to hold on to each other in a way that the alcohol did not. You can see the water kind of bubbling up. Now, if you were to try to do this at home, you would need the parchment paper. It's not going to work on just the countertop because water also it tries to adhere to other things as well. It also sticks to other things. And so the countertop doesn't really work because it's also trying to stick to the countertop at the same time that it's trying to stick to itself. Where here, it does not want to stick to the parchment paper, so all it wants to do is stick to itself, and it gives us this nice bubble effect. If I can do a little trick here, keep your eye on the water. All right, let's see if I can. It will move around on the paper a bit. Pretty nifty. All right, and now, just for fun, this is just kind of in addition. We're gonna keep on going with our water again. I'm gonna see how much of it we can get onto this penny. I did those first ones kind of quick. Now I'm gonna kind of slow it down a little bit. Let's see how many we can get on there before it breaks apart. The other liquids would not do this. If we were trying to do this with the rubbing alcohol right now, it would be all over the place. It would not be piling up like this. I think we're almost there. Oh, there we go. It finally burst. So you can see it piling up and clinging to itself as its first instinct. So there you go. Cohesion, water's ability to stick to itself. All right, for lab number 2, we are still on cohesion, but one of the other things that is created through cohesion is this thing called surface tension. Kind of almost a membrane at the top of the water as it grabs hold of itself. It creates this surface tension, and we're going to demonstrate how this works. All we're trying to do is to get the paper clip to sit on top of the water. Now, there are some people who are talented enough to be able to do this by just dropping it on there. I'm going to try it that way first and assume that it probably won't work. Well, drop straight to the bottom. All right, so what you do if you're not talented enough to do that, and you can make a little tool, take another paper clip and just kind of bend it into an L. And then you lay a next paper clip on top of it and just gently, if I'm talented enough to do it this way.
Nice.
There we go. We have paperclip. It is not floating. The paperclip you saw with the first one, they don't float, they sink. This paperclip is not floating. It is sitting on top of the surface tension. Now what we're going to do is add some rubbing alcohol to this. The rubbing alcohol will dilute the water, and eventually the paper clip will no longer be able to sit there. So let's see how much rubbing alcohol it takes. I'll try not to just drop it right on it, because that would, whoop, there we go. And the paper clip is down to the bottom. Now I may have broken the surface tension with the drops that were going in, or it may have been the alcohol itself. Usually it takes a little bit more to dilute it, so I might have done that with the drops being a little too, I don't know, help me out here. What word should I use here? The drops were being a little too aggressive. Yeah, there we go. That's a good word for me. All right, so there you go. Still cohesion, but that surface tension that sits on the top of the water can be helpful to some animals. There are certain bugs and some other organisms that are able to use that surface tension as part of their livelihood. They sit on top of it as part of that ecosystem, yeah, part of their surroundings. So lots of different reasons for why that surface tension can be valuable, but I just wanted to let you see what that surface tension looks like for your own eyes. So there you go. All right, here for the third lab. This one is going to be more about adhesion, which is water's ability to stick to other things. Because of its hydrogen bonds, it can stick to itself. But it also, as a polar molecule, it has another charge at the other end that allows it to be able to stick to other items. So for this lab, demonstrate this adhesion, I have an empty, this kind of all came in a kit together, but it's a mason jar. It looks normal here, but rather than having the regular cap underneath, it's got a screen. And so the water, just to prove to you, the water is capable, it's going straight through the screen. In order to fill it up, I'm gonna fill it all the way up, pretty much. Hopefully this works. All right, I'm gonna take the card and place it on top here, nice and steady, and give it a flip. Let's see if I have the seal on here properly. All right, so the paper is there now. If that's not cool enough for you, I'm gonna pull this out, the laminated card, I'm gonna pull it away, and the water is still going to stay in the jar. That is adhesion. A little bit of surface tension may be going on there as well, but the water molecules are grabbing onto the screen, and as they grab onto the screen, they essentially kind of form a wall or a floor at the bottom of this that won't let the rest of the water out. Now, just to show you that there is no trick here, I'm gonna tilt this jar just a little bit, and that's gonna be enough to break the screen, and all the water is gonna come piling out. There we go, adhesion. All right, for our last lab, really we kind of have it's kind of supposed to be an adhesion lab as well. But there's some cohesion involved as well, kind of a couple of different things that are going on with this lab. This one's just kind of mostly fun to watch. So we're just kind of having some fun with this one to see what happens. As you can see here on the parchment paper, I've got four toothpicks so far. I'm gonna do the fifth one for you, just to demonstrate. All you do is just snap it as close to as half as you can. It's not ever gonna really be perfect. But then you have all 5 of your toothpicks lined up like that, like kind of a crazy, scary intersection if you're learning to drive. And what we're gonna do now is take a dropper, and we've got the beaker full of water, and I'm just gonna put some of this water onto each of the corners. I'm gonna get them nice and wet. Get plenty of water on each of the corners. And we're gonna watch what happens to these toothpicks. Probably good.
Some movement happening.
All right, so what we have going on here, a couple of things. Some of it does have to do with the cohesion, with the water's ability to stick to itself. And then a lot of what's going on here is adhesion. The water is sticking to the wood. Really, I mean, the molecules themselves, on a molecular level, they're kind of soaking into the wood and sticking to the wood in that way, kind of up inside of it even a little bit. And that is expanding the wood a little bit and changing its position as the water sticks to the molecules that are part of the wood, and kind of just stretches it out or bends it, fills it up a little bit, changing the shape of our bent toothpick. There you go.